Now, let us consider the consumption part of the model. Every household consumes some quantities of goods. So, the alternative objects for in are nothing but the usual consumption bundles. Let us consider household H. A consumption bundle is an n-dimensional vector which tells us what are the quantities of good 1, good 2, etc., good n, which are consumed by our subject. The set of all possible, which is here this element of the n-dimensional PDS space. The set of all possible elements of consumption bundle, you remember by Pacini, is the so-called consumption set, which we shall denote by large X with H, which is a subset of the n-dimensional Euclidean space. Usually, we shall make the assumption that XH is equal to the non-negative ortant of the n-dimensional Euclidean space, but as Pacini told you in the first part of the course, this equality is not necessarily verified. However, for sake of simplicity, in our graphical examples, we shall always suppose that this equality is true. But the consumer is not only characterized by his consumption set, but also by his preferences. We introduce the so-called preference relation, but put attention, the relation that we shall consider is the strong preference relation, the relation which is denoted in masculine and adults this way, strict preference. I shall denote in my notes this relation with pH, preferred by the subject H. From a mathematical point of view, pH is a subset of the consumption set times the same consumption set. This means that pH is a set of pairs of consumption bundles. We shall say that the consumption bundle is X prime H is preferred to XH if and only if this pair, this couple, belongs to pH. Is it clear? This is a more correct mathematical notation for a binary relation. The first element of this pair is preferred to the second. This is the same that writing X prime H strictly preferred to XH, or X prime H preferred to XH, and so on. All these notations are equivalent. This is the most familiar one to you, but I shall use this notation because it's from a mathematical point of view more appropriate. This is, since this preference relation is a strong preference relation, it is irreflexive. You remember, in other terms, no bundle can be strictly preferred to itself. This is a well-known property of strict preference, of a strict preference relation. Finally, our household is characterized by its initial endowment of goods, which is nothing but a particular consumption value, so to speak. The initial endowment will be denoted as usual by omega h with components omega h1, etc., omega h m, which is an element of the n-dimensional Euclidean space. It is not necessarily an element of a consumption set. It could lie outside the consumption set. But besides the initial endowments of goods, remember that every household is an owner of one or more than one first. They have some shares in the property of a first firm, of a second firm, etc., on the large F firm. This C1H, C2H, etc., CFH represent the shares in the property of the first firm, second firm, etc., of the high H household, H consumer. H consumer as a property of this share of a first firm, and so on. Is it clear? This last part was not explained by Pacini in his part because it's not necessary in consumption theory, but absolutely necessary in general equilibrium theory. Otherwise, as we shall see in a moment, Varro's law would not be verified. Well, to this point, we can define the budget correspondence, another familiar concept by the first part of the course. Before this definition, we must define the wealth of a consumer, obviously. Wealth will be denoted by W of P. Note that in this context, W does not represent the price of a factor, but the level of wealth. How it is defined? As the value of initial endowment, so sum for I will change it from 1 to n of pi times omega hi, and this is the definition by Pacini. But note, plus the shares in profit due to these shares in profit. So, plus sum for f, which ranges from 1 to large f, of C f h times pi f of p. In other terms, if I am the owner of 10% of the shares of firm F, I shall receive 10% of its profit, and so on, for all the other firms. This is the level of wealth when you consider also these shares. Note that this function is only defined in the set lambda. You remember lambda was the set of all the price system according to which every firm has a maximum profit. In order to define pi f of p, it is necessary that P belongs to this large lambda. Outside the large lambda, the wealth cannot be, generally speaking, cannot be defined. So this function lambda is defined in lambda and takes values in the real lambda. Is it clear? After defining the wealth, consumer's wealth, we can define, finally, the budget correspondence. Another familiar concept, of course. The budget correspondence will be denoted by BH. This associated with every price system P in lambda, this set of all the XH which belongs to large XH, such that the value of XH, as I write it in a compact form, is not superior, H, is not superior to the wealth of a consumer. Is it clear? Anyway, this is the usual definition of a budget constraint. I can buy any consumption bundle whose value does not exceed the initial wealth of a consumer. And it is represented the usual way. For example, if the consumption set is equal to the non-negative order and all prices are positive, you obtain this budget constraint. The budget correspondence associated with every P with this set. So the budget correspondence is defined another time in lambda and takes values in XH in the consumption set. Is it clear? All is very familiar. This is the set in which our household chooses according to his preference relation. And we, exactly as in the case of a productive firm, we shall suppose that also the consumer is a maximizing subject. How to define the optimal choice of a consumer by means of a reflexive preference relation is very simple. A point, a bundle XH like this, for example, will be chosen, will be demanded if and only if its preference elements, the set of its preference elements, suppose that this is the set, is entirely outside the budget constraint. In other terms, with respect to this XH, it is impossible to find any better bundle according to the consumer's preferences. Is it clear? So, in this way, you can define the demand correspondence. Which will be denoted by DH. It associates with every price system P in lambda, also in this case, the set of all the XH which belongs to the budget constraint, such that P, H, bundles which are preferred to exchange intersecting BHOP is empty. Is it clear? A bundle XH, which belongs to the budget constraint, of course, will be demanded if and only if the intersection between its preferred elements and the budget constraint itself is empty. There is no better alternative in the budget constraint with respect to this XH. So the demo correspondence will be defined in lambda and take values in the consumption set, to be precise. But note that this set could be empty. Even if every firm is able to maximize its profit, so there is a definite choice for every productive firm, it is possible that, according to the same price system, some household does not succeed in maximize his preferences according to this rule. This may happen, for example, by discontinuity of preferences, you remember, by Pacini, or because some price is not positive. Because, you remember, if some price is, for example, negative, for example, the price of good one, the budget constraint will be this set. And clearly, if you have, for example, monotone preferences, no solution at all exists for our consumer, because for every bundle there is another bundle in the consumption set with all components greater than the original bundle, so it is preferred to the original bundle. No solution at all exists. Naturally, you can represent preferences by means of a utility function. Clearly, you remember, this problem can be converted in a problem of utility maximization. So, the set DH of P, if there exists a utility function which represents our preference relation, can be alternatively defined in this way. The set of all the elements of a budget constraint such that the utility of subject H in XH is greater or equal to the utility of any other bundle in the budget constraint. I hope you see this last part of the definition. I repeat, if you can represent the preference relation by means of a utility function, you can redefine the budget, the Demo correspondence in this way. The Demo correspondence associated with every price system, the set of the bundles of the budget constraint, such that their utility is maximum with respect to every other bundle in the budget constraint itself. If, I repeat, if there exists a UH which represents PH, these two definitions are absolutely equivalent. But all these assertions are quite familiar to you, I hope, from the first part of the course. So I will not study the properties of this Demo correspondence or over budget correspondence and upper M continuity, lower M continuity, and so on, because were explained by Pacini in his part. Let us have another short interval.